Hi user, welcome to my channel Learning with Khatak. In the part 4, we want to show that how to divide a datasets into 3 parts, this time a training dataset, testing dataset and a validation set sum. If you remind in the previous part 3, we have divided the training dataset into 2 parts, that is training datasets is divided into 2 parts, that is training dataset and testing dataset sum, and then we applied the cross validations with the 5 folds, and also we look that how a cross validation will be performed and what actually happened in the cross validations, that each samples basically equally have an opportunity to be in a training set and or in a testing sets. This time we want to divide the whole data set into 3 parts, that is training data set, testing data sets and validation sets. How this will be done? If you look at this, now this is the whole data sets, model fitting, the training data sets, validation sets and test set. Why we perform all these things? If you look at this, the danger of overfitting the parameters and the validation set sum. This is the model fitting, because when we train our model on a specific training set sum, then obviously if the training data sets contains a samples of one class, a majority sample of one class, definitely the model will be tilt towards this particular class. Means in a case of predictions, our model will be overfitted and every time this will be tilt toward the majority class. So how the data sets will be divided this time into 3 parts. If you look at this, first time I divided the data sets into 2 parts, X train, X test, and the second part I divided the data sets into X train, X validation, training set and validation test, and then training and validation. So if I run this, this is simply size of training data sets 84 size, size of validation 28, test set. Now this time 84 samples are inside the training, 28 are inside the validations and 38 inside the testing. So this time after prediction, after predictions we will validate our model, that how much accurate our model is by validating, by providing unseen samples. So here I what I did, that best score is equal to 0 for n is equal to up to these are the different neighborhood samples of the KNN. And for weight, both the weights can be checked, either the uniform and distance, that what parameters, this is basically the parameters, that what parameters gave us a best performance by the model. For each combination of parameters train KNN. Now here what we did, that for weight we train our model for uniform and for testings for numbers of neighborhood samples. So okay, if I run this code, now best score on validation set is 1, best parameters if n number of neighbors is equal to 9 and weight is uniform, test score with best parameter is equal to 1. So mean in testing means when we provide some sample from the testing sets, it give me 100% score, 100% accuracy if I use the weight uniform and the number of samples neighborhood sample is equal to 9. Okay. Then model improvement using hyperparameters tuning with cross validations. How to improve our model by using hyper tuning of the parameters and using with the cross validations. For a better estimate of the generalization performance, instead of using a single split into a training and validation set, we can use cross validation to evaluate the performance of each parameter combination. So if I run this code, look at this. Now this give me, if you look at the code, what actually, again for weight, uniform and distance, that will be checked, and then score cross validations, I applied a cross validation score, and then if we got a better score, store the score and parameters. For each better score, store the relevant score with the relevant parameters through which we can get a maximum performance. Okay, and then this is now best score on validation sets 94, and then best parameter is equal to if number of neighborhood samples 3 and weight is uniform. Okay, now train model count, this will be how the model training will be covered in the next lectures. GridSearchCV, a meta classifier. To use the GridSearchCV class, you first need to specify the parameters you want to search over using a dictionary. GridSearchCV will then perform all the necessary model fits. Now here in this case, we provide all the possible parameters in a dictionary and then want to select suitable sets, a best performance set of the parameter for our resultant model. So if I run this, so this is the dictionary. In neighbors is the basically name of so this is the dictionary. Param grid is the dictionary with the neighbors 1 to 10 weights, uniform and distance, and then I applied this grid search CV. If you look at this, param grid CV is equal to 5 to train the model. So I train the model which gave me the best parameters. GridSearchCV estimator classifier, param grid, this is the number of nearest neighbors and these are the weights. Fitting the GridSearchCV object on not only searches for the best parameter, it also automatically fits a neural model on the whole training datasets with the parameters that yielded the best score validations performance. And how we'll do that? Now grid search, applying the grid search, this, if you look at this, that give me 100% accuracy. Choosing the parameter using cross validations, we actually found a model that achieves 100% accuracy on the test set. The important part here is that we did not use the test set to choose the parameters. Here we did not use the test set, rather we use the grid search parameters. The grid search, which is basically have a dictionary of nearest neighbors and the best weights parameter. So if I run this, let's give me that if nearest neighbor is used 3 and if we use the weight parameters is uniform, then we can get a 94% accuracy of overall model. Again, be careful not to confuse best score with the generalization performance of the model is computed by the score method on the test set. Using the score method or evaluating the output of the predict model employs a model training on the whole training dataset. The best score attributes store the mean validations. This is the most important thing. The mean validation, cross validation accuracy with cross validation performed on the training data sets. So this is the grid search estimators 3, and then analyzing the results. If we analyzing the results, this is basically the mean fit time array. This is basically 4 features, mean times, and this is the fit time, mean score time, standard deviation score time, and many things out there. So weight, distance, etc. you can analyze this output by yourself. I am here nested cross validation with grid search, the overall mean and the overall validation scores here. So cross validation score 96, 1, 96 and 1. So mean cross validation is 97.33% using. So you can use even the following algorithms: decision tree classifier, Gaussians, NB and logistic regressions for the same grid CV search and cross validations. So thank you very much for being with us.